Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to basic concepts related to electrical machines. So in the previous video we discussed about magnetic materials and the classification of magnetic materials, and we discussed specifically about uh, the diamagnetic materials. So in this video we are going to discuss about the paramagnetic materials. So just a quick recap. So we know that every object or material, they're affected by magnetic fields. So when an object is placed in a magnetic field, uh, because of the influence of the magnetic field, it can attain magnetic properties. So to which extent it acquires magnetic properties, how strong or how weak it is, it depends on certain properties. The important properties related to magnetism, which we have discussed: magnetic flux density, magnetic permeability, magnetic susceptibility, intensity of magnetization, magnetic intensity, all that we have discussed. So you can check that video first, then the other videos. So this magnetic property of the substance is because of the orbital movement of electrons, which behaves like a current loop, and that behaves as a magnetic dipole with the orbital magnetic dipole moment given by this. We have already covered it. So the classification of magnetic materials is into three categories: diamagnetic, paramagnetic, and ferromagnetic materials. Diamagnetic we have covered. In this video we are going to discuss about paramagnetic materials. So paramagnetic material is one, when it is placed in an external magnetic field, it is weakly magnetized in the direction of the applied external field. So in diamagnetic, it was weakly magnetized in the opposite direction. Here it is in the direction. So let's say we have a material, let's say this one in the middle, it is placed in the magnetic field. So it is magnetized in such a way that the opposite extreme ends of the material, they acquire opposite polarities with respect to the polarity of the magnetic field in which it is placed. So it means that the end which is towards the north pole of the magnetic field, external magnetic field, that will acquire south pole, it will become south pole opposite, and the one which is facing the south pole of the external field, that will become north pole. So here, as opposite to the diamagnetic materials, the object, it will get attracted towards the external field, not repelled. In case of diamagnetic, it was getting repelled weakly, yes, but repelled. Here same weak intensity, less intensity, but it is getting attracted, opposite. So that is the basic difference between diamagnetic and paramagnetic. In diamagnetic, it was getting weakly repelled. In case of diamagnetic, north facing end acquires north pole, south facing end acquires south pole. Like poles repel each other, that's why it was getting repelled. In case of paramagnetic, it acquires opposite poles. North facing acquires south, south facing acquires north, that's why it gets attracted, but weakly. The intensity is not great. Examples of paramagnetic materials are aluminium, antimony, chromium, lithium, oxygen, copper chloride, sodium, tungsten, to name a few. Now, the magnetic field which gets induced in the direction inside this material is weak. it is of weak intensity. So similar to diamagnetism, these paramagnetic materials, they lose their magnetic characteristics, whatever feature they acquire, as soon as this external field is removed. They do not retain it. In case of diamagnetism also, that repelling nature, it loses that behavior as soon as this magnetic field is removed or it is taken away from this magnetic field. So in both diamagnetic and paramagnetic, one thing is common, is that they lose their magnetic behavior, the induced magnetic behavior or the forced magnetic behavior, as long as the external magnetic field is removed. Okay, now what is the cause of paramagnetism? Now in case of diamagnetism, we know that whatever magnetic property a material or a substance has, it is because of the magnetic dipole movement, because of the orbital motion of the electrons, which constitutes an orbital current in the opposite direction, and that current loop, it behaves as a magnetic dipole. And that dipole moment, the orbital magnetic dipole moment, is responsible for the magnetic behavior. In case of diamagnetic materials, the magnetic dipole moments used to cancel each other out. They existed in pairs, equal magnitude, opposite direction, no net dipole moment. That's why weak magnetic behavior, repelling type magnetic behavior. But in case of paramagnetism, even though the characteristics are weak, the magnetic characteristics are weak, but they attract the magnetic lines of force because they get magnetized in the direction. So what is the reason behind that? Is that when a paramagnetic material is without the influence of the external magnetic field, when it is away from a external magnetic field, the orbital magnetic dipole moments, because of the revolving electrons, they are randomly aligned in random directions. But when it is placed in an external magnetic field, they get aligned in the direction of the magnetic field, in one direction. So the net resultant of all these orbital magnetic dipole moments, because of the orbiting electrons, that constitutes a non-zero dipole moment. The magnitude is very less, yes, the magnitude is very less, but it is greater than zero. Less but greater than zero. And because of that, paramagnetic material acquires this kind of a characteristics. Opposite ends of the extreme ends of the paramagnetic material, they acquire opposite polarities with respect to the polarity of the magnetic field in which it is placed. So there are some properties of paramagnetic materials which are important, like we discussed in diamagnetic cases. Paramagnetic material, in the paramagnetic material, the magnetism which is induced, it is weak and this kind of a attractive type. So it is weakly attracted by a strong magnet because of the weak magnetization, attractive type magnetization, which is developed in the direction of the applied magnetic field. When a paramagnetic material is placed in an external magnetic field, the magnetic lines of force, they move into the material, through the material. But in case of diamagnetic, they moved away from the material, passed away from the material. They did not crowd into the paramagnetic material. So we can say that even though the magnetic characteristics are weak, they are attractive type. That's why the magnetic lines of force, they are allowed to pass through the paramagnetic material. Next, when a paramagnetic material, it is placed in an external magnetic field, it aligns itself in the direction of the magnetic field. Why? Because opposite poles, they attract each other. North attracts south, south attracts north. So that's why it gets aligned with its longest axis in the direction parallel to the magnetic field, external magnetic field. But in case of diamagnetic, the longest axis was perpendicular. Okay, it was perpendicular because in that case it used to repel. This was north, this was south, north north repel, south south, it used to repel. But in this case it is attractive type. So north attracts south, south attracts north, so it's always, its longest axis is parallel to the external magnetic field. Then the other important characteristics, that is the permeability or the relative permeability of a paramagnetic material or substance is more than one, which explains why it acquires attractive type magnetic behavior because of the non-zero orbital magnetic dipole moment. It is just greater than 1, it does not have a very high value, it's just greater than 1, not very high value. As compared to diamagnetic, it was just less than 1. In case of diamagnetic, just less than 1. That's why diamagnetic used to get weakly repelled, because it was just less than 1. Just less than 1, so weakly repelled. It is just more than 1, that's why weakly attracted, the permeability. So the conductivity for magnetic lines of force is greater in case of paramagnetic material, but in case of diamagnetic there was no conductivity of magnetic lines of force. That's why they never used to pass through the material. Then is susceptibility, the relative ease with which a substance is magnetized. It also has a small positive value, whereas in diamagnetic it used to have a small negative value. So it was very weakly magnetized in the opposite direction, so negative value small. It is weakly magnetized in the direction with attractive characteristics, that's why it has a small positive value. Then another important characteristic of paramagnetic material is that the susceptibility of a paramagnetic material is inversely related with the surrounding temperature. So when the temperature is high or the temperature increases, susceptibility decreases, and vice versa. So these are the important characteristics of paramagnetic materials. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.